All right, so this is your motion of a free-falling object. I write this on here because it's true, and people that are in physics like to see this because it reminds them of their physics class. And then these are your coefficients due to gravity, the acceleration, pulling you down, the gravity pulling you down. You don't have to memorize these. Again, it's just true, so I wrote it on here. And again, people that have taken physics like to relate what we're doing here to what they've done in physics. So if you're using feet, then your A value would be -32 feet per second squared. And if you're using meters, it's -9.8 meters per second squared. This one says, suppose a ball is dropped from a window 20 feet above the ground. Position is given by this function. That's going to bother me that the SST is over there. Let me fix that. Find the height of the ball after 1 second. So we're just going to plug 1 into the position function. So just find the height at time 1. So if I plug in 1, I will have -16 plus 20, so that would be 4 feet. So the ball was dropped out of a window at 20 feet above the ground, and after 1 second, it hasn't hit the ground yet. It's still 4 feet above the ground, so it's still falling. And then it says find the velocity after 1 second. So we're going to find velocity and then plug in 1. And we're going to expect this to be negative because the ball is falling. So it should be a negative velocity. So this derivative would be -32t. And if we plug in 1, we're going to get -32 feet per second. All right, C, when will the ball hit the ground? All right, that is when position is 0. If the ball is on the ground, then this position is going to equal 0. And I realize there's another part to this question, but let's take care of this first. So I'm going to set the position equal to 0, and we'll solve that. So subtract the 20, negatives are going to cancel. Divide by 16. So 20 over 16, that will reduce to 5/4. And then square root. So square root of 5 is just square root of 5. Square root of 4 is 2. So square root of 5 over 2 seconds, whatever that is. But that's when the ball hits the ground. And it says, what is its speed at that moment? So we want to take this time, plug it back into velocity, except we want to make it positive because remember, speed is the absolute value of velocity. So we're going to plug this back into velocity, but we're going to make it positive. So basically just ignore that negative sign there, and it would be 32 times this time. And then that would be feet per second. So again, just remember if it says speed, you need to make it positive. Think of the speedometer in your car. It's never going to go negative, even if you're driving backwards. All right, and then last one. A ball is thrown upwards from the hand of a player. When it leaves his hand, it's at a height of 2 meters and traveling at this speed. Position is given by this equation. All right, so what is the speed of the ball after 1 second? So we're going to find velocity, and we're going to plug in 1, but just make sure we make it positive because it says speed. All right, so finding this velocity. That's 9.8, right? In my head, yes, -9.8 t plus 5. And we're going to plug in 1. So that'll give us the velocity at 1, but then I need to absolute value that. So if I plug in 1, -9.8 plus 5 is -4.8. And then I'm just going to make that positive. So positive 4.8. This one was meters, right? Meters per second. All right, letter B, when, so I'm looking for a time, when is the ball 3 meters above the ground? So that's when position is 3. So I'm going to set this position equation equal to 3. And I am definitely going to need a calculator for that. So I'm going to put all of this into Y1 and then the 3 into y2. All right, so negative 4.9x squared plus 5x plus 2. And then I'm going to put 3 into the y2. We didn't have an interval given for this one. Mine's at 0 to 10. I'm going to just leave that 0 to 10. We'll see if that's good. I think my y maximum is going to need to be quite a bit bigger. Let me make that 10. We'll see how this looks. I may need to adjust it. Oh, okay, well, that's way too much. Let me reel that back in a bit. Let me make them both 5. There, that's a little bit better. All right, so there are actually 2 times when the ball is 3 meters above the ground. So it hits 3 meters once on the way up and then also once on the way back down. So I'm gonna go to calculate intersection. Now, first curve, second curve, you can just hit enter. This time the guess is actually kind of important because it's gonna give you whichever one it's closest to. So I'm gonna go to the first one. And so that is time 0.273 seconds. And then we're gonna have another time. So I'm gonna have to do all that again. So calculate intersection, first curve, enter, second curve, enter. And for guess, I'm just gonna move the cursor close to the other one and it'll give me that one instead. So 0.747 seconds. So once on the way up and once on the way back down. It goes through 3 meters. C is when does the ball hit the ground? So that would be when position is 0. So I'm going to take the position function, set it equal to 0. And I already have this typed in here, so I'm not going to retype it. Basically, just ignore the line at 3. Or here, you know what? I'll just go get rid of it. Let me clear that out. So this is the time that we want. So now we want to calculate a 0. So calculate 0. It appears to be between 1 and 2. So left bound, I'm going to do 1 enter. Right bound, I'm going to do 2 enter. Guess, I'm going to put 1.5. And it will give me that time. So 1.327 seconds. And then the last one, when is the ball at its highest point? Okay, so the ball goes up and comes back down. The highest point is going to be right here. And that is when velocity is going to equal 0. If I draw in that tangent line, it's going to have a 0 slope. So we want our velocity to equal 0, which I think we already found the velocity, didn't we? Yeah, it's right here. So negative 9.8 t plus 5 equals 0. And so we're going to subtract 5. Negatives are going to cancel, which is good because we're looking for a time, so we don't want a negative time. So 5 over 9.8 seconds, whatever that is.